Hello friends, welcome to edupediaworld.com, your destination to online education. Friends, today we are going to start with the kinetic molecular theory of gases. But first of all, let's recall the last session which we have learned about chemical classification of matter. Let's focus this. We learned that the atom, that is the smallest particle of an element, this is basically a basic unit of matter, and the element is made up of atoms or group of atoms, which is a molecule. Now, if we see next, it will be the compound, that is the substance or two or three elements combining together, that is chemically combining together with each other to form a compound. That is a The substance or is composed of two or more atoms or a group of like or different atoms held together by chemical forces. That is a compound. Like for example, see this. This is a compound of any kind of elements. Now, if you focus on the mixture, what is mixture? A mixture can be vary in quantity. The mixture consists of two or more different elements. It can be compounds. They are just physically together. They are not chemically joined together. That is a they as they can physically separated, that is they can be physically separated by all the physical methods, but they are not chemically combined together. So there is no chemical combination between all the elements or compounds containing into the mixture. Now you see the pictorial form, that is yes, these are the elements which we keep in the periodic table. This periodic table we'll be going to learn in the next few sessions. And this is a mixing of every 2-3 liquids into different quantity. It can be mixture, for example air is a mixture. Now this is a compound, they are the chemically combined together, that is hydrogen. Two hydrogen are combined to with the oxygen to form a water. This is a compound. I hope you have understand the last session. Now let's start with the new session, that we'll be going to learn is a kinetic molecular theory of gases, in which we'll be going to details of for temperature and pressure. Now friends, let's recall the characteristics of gases. What are the characteristics? First of all, let's see. Let's write down the characteristics of gases. First, yes, the molecules are far apart. If you compare to liquid and solids. Secondly, if we see, there is a very negligible force of attraction between the molecules. There's a one more characteristics of gases, that is a molecule move faster than liquid and solids. Yes, that is the kinetic energy of these molecules are much higher than the liquid or solids. Yes, the gases are called fluids because they can easily flow. Fifth, if we say the collision part, that is the collision between the molecules is very less. Basically, it depends upon the temperature and pressure, also on the volume of the gas. Six, if we say if a gas exerts pressure, and due to the continuous bombardment by its molecules, what does the 6 point means? That is when the pressure is exerted by the gas, the molecule collide very fast. That is the kinetic energy of the um, molecules to collide goes on increasing, and the molecules come closer and closer, so the fluidity decreases. Yes, so these are the characteristics of gases. Now let's come to the kinetic molecular theory of gases, that is deriving from these characteristics. The kinetic molecular theory has been derived. Now, what the gas actually explains us, yes, is basically it describes the nature of the gases, that is the molecules of the gases. First, it also describes the relationship between temperature, pressure, volume of the gas, of course, and the quantity of gases. This means how the molecule react when the temperature is increasing or pressure is increasing, or vice versa, or the quantity of the gases is changed. What happens to the molecules, basically how they behave in these particular characteristics, right? It also explains the kinetic movement of the molecules of the gases, right? Now let's see the postulates of this KMT theory of gas. Now, what is KMT theory? That is, what is kinetic molecular theory of gases? What does it explains us? That is, that this theory describes a gas which has been composed of molecules, of course, that are in constant random motion, as I told you. The theory helps to explain the relationship exist between the temperature, pressure, and the volume, and also the quantity of the gases. Now let's come up to the postulates of KMT of gases, that is called kinetic molecular theory of gases. What is the composition? First, composition of gases. What is composition of gases? Yes, the gases are made up of very tiny particles, we call it molecules, moving in all the possible direction in all possible speed, whatever the gas have. The molecules are basically negligible small in size as compared to volume occupied by the gas, right? We can explain by drawing in a small diagram. That is, it says, this is a vessel. Here the gases are, these are the molecules of the gases. It says that the molecules are very tiny, as it is the gases occupying all these spaces, right? For example, if you boil a water, if there is steam coming up, steam is being into proper takes basically they occupy space, some space, and if you take one particle out of it, that is a molecule, right? Now if we come to the next postulates, that is, a gas have neither fixed volume nor fixed shape. Yes, gas cannot have a fixed volume or no, cannot have a fixed shape. Why? Because there is a negligible force of attraction between the gas of molecules. Therefore, the molecules are free to move in the entire space available to them. Whereas if we closed any of the gas into the container, and they attain the shape of that particular vessel, or so you can say the container, right? Now third postulate says the gas exert pressure in all directions. Yes, of course. Let's suppose we are blowing a balloon. We all blow the balloons in our birthdays, in some occasions. So let's blow an balloon. We are giving air into the balloon with a flexible walls, right? They are flexible walls. Now if we are exerting pressure from here, the pressure is being exerted from the walls of the to the walls of the balloon, and hence the balloon goes a bigger into the bigger size. That is, if we explain the chemistry form, that is, the moving molecules of the gas collide with each other and also with the walls of the container. Due to these collisions and the gas molecule exert pressure, it has been found that in a given particular temperature, the number of molecules of gas striking against the wall contains per unit time per unit area is the same. I hope you have not go understand this particular line. I'll explain you later on. Thus, the gas exerts the same pressure in all direction. What I'm trying to understand is, when we'll come to the pressure part, I'll describe you the particular line. The fourth is, a gas are highly compressible. How? Yes, there's a large intermolecular space between the gas molecules, as we have seen. Let's see how. I have made this vessel for gases. If you compare to the vessel of liquid or vessel of solid, this is a solid. Here the molecules are like this. And here molecules are slightly having some space into the intermolecular. Here the spaces between the intermolecules are higher than liquid. This is a liquid, and very high from the solids. You can see from these vessels, these three vessels. So if we understand this, there is a large intermolecular spaces between the gas molecules, and this accounts for the high compressibility of the gas. When we apply pressure, the gas molecule come closer, thus they decrease in the volume of the gas, right? Now if we see the fifth postulate, what does it say? That it is, the gas is are highly expansible. What is expansible? The gas, it is actually the gas increase in volume on decreasing pressure or and increasing temperature. For example, take a vessel and fill the vessel with the gas. Now, when the pressure on an enclosed gas is reduced, right, its molecule move apart, thus the increasing the intermolecular spaces. As a result, the volume of gas increases, right? Now, if we see from the second part, that is the temperature part, when the enclosed gas, that particular vessel, if we heat that from outside, the kinetic energy of the molecule increases, right? The molecules, energy of the movement, that is the movement of the molecule increase very high, and thus the molecule move faster and farther from each other, resulting in the increase of volume of the gas, right? This is called, the gas is highly expansible, right? Now, what is the uh, sixth postulate says that the gas have low density. What is density? The mass of gas per unit volume is very small due to the large intermolecular spaces between the molecules. Thus, the gases are low density. What is density? Dense. Let's see from the example. We have made three vessels. See how dense the solid is, and as compared to the solid, there's a less density in the molecules in the liquid as compared to solid, and hence the gas, as the intermolecular spaces is very high, so the density is very low. Now let's understand the seventh postulate, that is a gas have a natural tendency of mixing with each other. What is this characteristics? That is, let's take an example. Many times you keep naphthalene balls, or let's say if you open a jar of a chlorine or ammonia in a large room, the odorless presence of the gas can be detected within a few seconds in every part of the room. How? The, as the chlorine is heavier than gas, it does not remain only at the floor level. So the molecules of chlorine coming out from the jar collide with the air molecules, hmm, right? And starts moving in the haphazard manner in all possible direction. That is the characteristics of any gas. In this process, as the process continues, till there is an equal concentration of chlorine molecules throughout the room. So we get the smell, or you can say the odor of the chlorine. Or second example, if you say when we light, you can say agarbatti. When you light a agarbatti and keep into the corner of the room, you can smell it into few seconds. This is the reason how. This process is basically called diffusion, in which the diffusion, it gradually, that is the gradually mixing of two substances and which come into the contact, like two gases mixing together gradually, is called a diffusion. Now let's come to the temperature of gases. Let's take an example first of all. Take a vessel, fill this vessel with the gas. These are the molecules of gases. It is at the room temperature. Now heat this vessel This is a lamp. These are the flames coming out. We are heating. Now what happened to the molecules? First of all, the movement of the molecule go faster. What happens? Two things happen. The kinetic energy goes on high. The intermolecular forces decreases. Pressure on the walls of container goes high, right? So we have seen as we increase the temperature, the molecular motion also increases. And when temperature decreases, if you reverse this process, like if we freeze, what happens? This is the vessel. If we freeze, the molecule come closer to each other, right? And the motion of the molecules decreases. And there's one particular temperature where the motion goes zero. We call that temperature as absolute zero. This is the temperature at which all the molecular motion ceases, that is, comes to an end. I hope you have understand with the example. Now, if we read out, that is, the temperature and the energy of gases are directly proportional. As the temperature increases, kinetic energy of the molecule also increases, and vice versa. Let's see this. How? There are two vessels. One vessel having a temperature of 4400 Kelvin and one having 50 Kelvin. First, having a high temperature, the kinetic energy increases as the temperature goes up, and second one, it decreases as temperature goes down. Now this, having an example with the activity, let's blow one balloon and keep the balloon into boiling water. What happens? The the molecules of that particular into the balloon, the kinetic energy increases and the balloon goes into the bigger size as compared to the ice water. You can see this. If we cool down, the balloon comes into a very small size. This, students, please do this activity at home and you'll understand the kinetic energy and the temperature part of the gas. Now let's understand. I hope you have understand the pressure temperature part with this example. And if you do it this activity at home, you'll be surely understanding the relationship between the molecular of motion of molecular gases and the temperature. Now let's go come to the pressure part. That's the pressure exerted by the gases. What happens actually? The force of exerted on an unit area of walls is equal to the pressure of the gas. What is that? Like for example, when a gas is being enclosed in a vessel, it exerted pressure on the walls of the vessel, right? And the reason is that the molecules of gas collide during their random motion with the walls of the container as well as within them, that is intermolecular collision. Since a large number of molecules suffer collisions with the wall and appreciable forces acts on the wall, the force exerted on the unit area of that wall is equal to the pressure of the gas, right? How as whole gas exerted the same kind of pressure, that is whole every molecule exert the same kind of pressure on the particular vessel wall of the vessel. So if we calculate the unit area, we'll come to know the pressure of the gas, right? And secondly, if we say that pressure is proportional to collision of the molecule, like when we increase the pressure, the collision of the molecule increases. See, like this, every molecule exert a collision or pressure on the container, and if we talk about only one kind of, or we calculate only one molecule of a gas, that is if we calculate the force of that particular molecule with which it is exerting pressure, we can calculate the whole of the gas. Now let's take an example now. Yes, again with the balloon. That particular vessel was basically a container which walls were actually packed. They are not flexible walls. Now if we talk about the flexible walls, that is a balloon, what happens to the balloon? When we exert pressure into the balloon, the air, what does, as we have seen, the molecules exert pressure on the walls of the container. Let's see, this balloon is having a wall, a flexible wall, and when the molecule exert pressure on the wall, it blows into bigger size. This is a pressure with respect to the collision of the molecules of the gases. I hope you have understand. If you do this activity at home, you'll be surely understanding the pressure. Now friends, just think fast. What does hot means for the temperature? What will removing all the kinetic energy do to a gas? Let's do it very fast. Let's do in 5 minutes. I hope you have understand this session clearly. Into the next session, we'll be learning about the gas laws. Thank you, students. Thank you to attend this session.